hear you properly. Can you speak louder once more?
Depression and freezing point and osmosis.
Yeah. Okay. So based on the last class, there is one question that we have left. So first, let's start the question with the question. Let's start the class with the question. So your question will be this: solve this and tell me the answer. Okay. When you're done, you can tell me. Okay.
Yeah.
You have 1 minute. Move. Then tell me which topic, from which topic this question is from.
Osmosis.
Yes. Have you remember the formula? What is the formula?
CRT. Molarity into gas constant into temperature.
Can you tell me again? What is it?
Molarity into gas constant into temperature.
It's equals to what? You're telling me the expression. It equals to
The
what?
osmotic pressure.
Yeah,
The osmotic pressure.
correct. Solve it. Done?
I got the expression. I think. I got the expression. I think.
You got the
I
expression.
got the
Fine.
expression, but not the
Fine.
finance.
Okay. I'm just solving it. See. So 300 temperature is given to you, which is 300 Kelvin. Fine. Given part. And the next is 1 liter of solution contains 171 gram of sucrose. Okay. So the next part is key weight of the sucrose. Sucrose is 171 gram. Fine. Determine the osmotic pressure in ATM. So OP I need to find. Okay. That would be
Yeah.
in pi. So just apply the formula. Pi equals to CRT. By that you need to find
Yes.
C. What is C? C will be the number of moles divided by volume.
Yeah, true.
Hmm? R is your gas constant. T is the temperature. This is this thing this thing you need to find. For
Yeah,
that, this volume is you know the volume, but how to find the number of moles?
one.
Okay. Do you know the formula of sucrose? What is the formula?
Is it the
Or
same
if
as
you do not know,
glucose?
huh?
Is it the same as glucose?
It is the
Same as glucose, or is it?
no. It is
Okay.
basically it is not same as the glucose because glucose is my monosaccharide and sucrose is my what? Disaccharide. Disaccharide means it is made up of two units of your glucose like thing. It is your basically addition of glucose and fructose together. Okay. So
Okay.
I'll tell you the weight. Basically, the weight would be 342. The weight would be 342. And how I am able to get this weight of sucrose? So if you want the formula, so the formula is C12 H22 O 11. But if you do not know the formula, then basically what is it? See, glucose is my type of carbohydrate. See, type of carbohydrate. And why I'm telling you this information, because this information is there in biomolecules. In your biomolecules chapter, this information is there. The glucose is a type of carbohydrate. Basically, the carbohydrates are those which is a polyhydroxy aldehyde or ketone. What do you mean by polyhydroxy aldehyde or ketone? It means that poly means many. Yeah, poly means many.
Yes.
Hello,
Yes.
poly means many, and hydroxy means OH group. Poly means many, hydroxy means OH group. That means
OH group.
a compound having multiple OH groups are there, and in which the main functional group would be aldehyde or ketone. Aldehyde or ketone. So that
Ketone.
one would be your carbohydrate. That one would be your carbohydrate. So if you
Carbohydrate.
see, so if you see my glucose. So in my glucose, what is the formula? C6H12O6. So if you see, if I'll form this one in a structural form, so the formula would be like this. It would be CHO H like H OH OH H H OH H, and this one would be a 1 2 3 4, and this one would be your 5, and this one would be your 6. Okay, so this is the formula of my glucose. See, 1 2 3 4 5 6. There are six carbon are there. So six carbons are there. If you calculate your hydrogen and oxygen, this will going to be equals to 6. Why? Because 1 2 3 4
Yeah.
5. 5 oxygen are there. 1 2 3 4 5. These 5 oxygen are there in hydroxy form. In OH form. See, oxygens are there in hydroxy form. See, 5 OH groups are there. 5. And one oxygen will be there in aldehyde, in your aldehyde, main functional group. Understood? So this is the
Yeah.
formula of your glucose. But what is your sucrose? It is the combination of two things. What is sucrose? Sucrose, why I am telling this, because it is there in your class, in your biomolecule. So there you also learned about this more. So sucrose, it is basically the disaccharide. What is disaccharide? What is saccharide? It is a saccharide is basically the carbohydrate. Another name for the carbohydrate are saccharides. Saccharide, right? Okay, it is disaccharide. Spelling is not correct. Disaccharide. Understood? And what do you mean by
Okay.
disaccharide? It is made up of two units. Two components. One would be your glucose and the other one would be your fructose. Understood? So basically,
Yeah.
see, if what is the formula of the glucose? C6H12O6. See here, C6H12O6. What is the formula of fructose? C6H12O6. Same formula is there for the glucose and the fructose. But what is the difference? The difference lie in between the functional groups. Why? Because in your fructose, the functional group would be my ketone, and in your glucose, the functional group would be your aldehyde. Understood? So how this dimer will form
Mm.
after combining these two, glucose and fructose, you how you gonna combine by just relieving the H2O. Just by releasing the H2O, you're gonna found this sucrose. Understood? So you will get the
Yeah.
sucrose. So if you see, this one would be 180 grams. This one would be your 180 grams. If you add both the 180 grams, you will get 360 grams. You will get 360 grams, but minus H2O. That means minus the weight of the water. So if you subtract 18 from the weight as the weight of the water, you'll get 342 grams. So this is another method of remembering this weight, 342 gram. Understood?
Yeah. Understood.
So basically, then 171 divided by 342 gram, and this one would be my moles divided by 1 liter, multiply by R. So what is the constant? R rate
Gas
constant
constant.
is what? Huh? 0
Zero
0.08
point eight five five.
0.021. Yeah, this is the R.
Okay.
And T is
Yeah.
what?
Yeah.
300. That's it.
300. Yeah.
Just by putting the values, you'll get your final answer as pi equals to 12.3150 atm. Okay, understood everything?
Okay. Yeah. Understood.
Yeah. So this is my question based on the colligative property. So we have done almost basically two-third part of the chapter, and in this class we are going to complete this chapter completely. Just one topic is left, which is the Vanta factor, and in this class the target is to complete that Vanta factor. That's it. And basically the questions of the Vanta factor are very much easier than this. Just one thing will be added. So let's start the Vanta factor. So what do you mean by
Okay.
Vanta factor? What do you understand? Do you heard this term Vanta factor before? The topic is Vent of,
Yeah.
huh?
Yes. Yes.
So can you tell me what is it? According to your knowledge, what is Vanta factor?
No, I've only heard about it. I don't know the definition.
Okay, okay, fine. See, so I'll tell you what is Vanta factor. See, so Van Hoff is the scientist name, and factor is what that
Mm.
we need to understand. So basically, first you should know the theory. So what will happen here is ki, let us take a blank page. See, I am having a, let's say, compound CH3COOH, this one. Understood? And
Yeah.
I am having glucose C6H12O6. I am having these two compounds. Now see, what is the difference between these two compounds? Let us observe. First, let us take a beaker. In that beaker, I have poured this CH3COOH. And in the same beaker, after let's take another beaker. Not, I'm not going to use the same beaker. So let's take another beaker, and in that beaker, water is there as a solvent. Water, water. Okay, clear?
Yeah.
Now, after
Yes.
after dissolving CH3COH, what will happen to this? Basically, this will going to dissociate into CH3COOH minus NH plus. Correct? Is there any doubt
Yeah.
here?
No. No. Yeah. Understood.
And what will happen with glucose? Nothing will happen with glucose. The glucose is going to be dissolved as it is at a single unit. Like this will be there in C6H12O6 plus water. There is no a dissociation or association thing happens with it. So if you see here, what is happening? The dissociation is happening. Like my original compound is this, but after dissolving into a solvent, my compound will be different, and my compound is in a different form, and the compound is dissociated, basically dissociated. So if the compound is dissociated, and what is this colligative property? So the concept of colligative property is that key, it is basically depends on the number of solute particles that we have discussed. Like if I take you to the previous topics when the colligative property is started. Okay, so this question is left. So we are going to solve this one as well. So just 1 minute. Uh, if you go back. Yeah, here. So see, in this page, see, colligative property arises for the solution in which the solid is non-volatile. The solution, how the solution is formed after dissolving a solute into a solvent. And specifically, if we are discussing about the colligative property in which the thing that we are dissolving is non-volatile. So if the thing is non-volatile, that means
Yeah.
that it is not going to be dissociated into. So if it is non-volatile, it means that it is not going to be evaporated out. The Weber pressure will be zero. But after forming the solution, the Weber pressure is decreased of what? Of your
Water,
solvent.
solvent.
Okay.
Yeah.
So basically the depression in the vapor pressure is happened. So this is the property that arises. And what are the colligative property? These are the properties which is arises after dissolving it. So what will happen is
Yeah.
key, in this solution, vapor pressure of the solvent decreases due to some properties. Now, all these colligative properties, mark my words, this is very important. All these colligative properties depends. See, this is an important word. Depends on what? Depends on, just 1 minute.
Solid part.
Depends on number of solute particles. Depends on what? Depends on
Number of
number of solute particles.
solid particles.
So it means that 1 minute. So it means that if my number of solute particle will increase, that means that my vapor pressure will be more decreased, and my elevation in boiling point will be more, and my depression in freezing point will be more if my number of solute particle is increased. This is the point from where the Vanta factor is related. See, now let's go to
Yeah.
the page. Okay, so let's go to this page. So now what is happening here? Initially here, if you see here in the glucose, my number of solute particle is the same that is there before adding into the solution. Is going to be the same after and before adding the solution. Here at this point where the solute is not added, and this point when the solute is added, the number would be same. But the problem comes where when the dissociation or association types of thing will happen like this. If you see here, initially the number is 1, after adding it will be 2. That means what we are doing here, we are calculating the properties, we are calculating the depression in freezing point, we are calculating the elevation in boiling point, we are calculating the relative lowering in vapor pressure, we are calculating the osmotic pressure based on the number of solute particles before adding into the solution. But the experimental value, the real value would be different. Why? Because the number of solute particles is increased, that which is there before adding into the solution. And if the number of solute particle is increased, it means that there is some factor that you have to be put in so that the formula is going to be characterized. Understood or not?
Could you repeat?
Okay, see carefully what I'm saying. The Vanta factor is a property which is a correction property. It is not a property, it's basically a correction. This is a factor which is introduced in order to bring the correction in a formula. What
Mm,
formula? In the formulas of the colligative properties. You know the formulas of the colligative property, like for example, RLVP. Your RLVP is equals to P naught A minus PT upon P naught A equals to mole fraction of B. But if I took a compounds like that will dissociate into the solution, it means that the compounds, if I take a compound, if I take a solute which is non-volatile, but in after adding the solution, the number is going to be increased. If you see here, the number is 1, but just adding into the solution, the number is going to be 1 and 2. The particle is going to
mm,
be dissociated, and the number of solute will be now 2. If you see here,
mm,
and colligative property specifically depends on the number of solid particle. It doesn't depend the nature. I have told you before that it is the most important point that you have to be remember is the colligative property is only and only property which depends on the number of solid particle. So if
mm,
the number of solid particle changes, the property will be changes. So if you see here, if we calculate all the colligative property, whether it would be osmotic pressure, whether it would be RLVP, whether it would be elevation in boiling point, depression in freezing point, any colligative property, if you calculate before adding into the solution, after adding into the solution, the answer would be the same. But the correction that we need is in the compounds which will be going to be dissociated or associated, like the compounds which will be going to be dissociated and will be going to be converted into more number of solid particles, or the compounds which will associate, like if the compounds are, like for example, if I add two compounds, okay, and after adding it, they will clumps up and form associate and form only one compound. So this is what, this is the association property. If such type of dissociation or association is happening, that means we need some correction in the formula. So for this correction, we are going to be introduced with Vento factor. Now have you understood or not? So see now the
yeah,
third,
understood.
again I'm going to be repeating third time. So all these colligative property are applicable only for those solutes which do not, see here, these property are only applicable, all the colligative property that we are discussing before is only applicable to those which do not get dissociate or associate, which do not going to be break down into more number of particle or clumps up to form a single unit. If such type of compounds are not there, then the colligative property is applicable. But if the compound is associating or dissociating, then there is a thing. For example, I mean, an example there. The example are NH2CO NH2. This is not going to be dissociate. Sucrose, this is not going to be dissociate. Glucose, this is not going to be dissociate. But in case of the electrolytes, ionic compounds that are going to dissociate, like the formula is not valid. See, the formula is not valid to calculate the molecular weight, because what we are doing, we are basically calculating the molecular weight. However, we try to calculate these molecular weight by using these formula, then there will be the answer would be wrong. Okay, so it is known as your abnormal weight. What is written here? However, if we try to calculate their molecular weights by using these formulas, then it will be wrong. And this is known as abnormal weight, the thing that you get. So to correct these formulas for electrolytes, Van't Hoff factor is introduced. Van't Hoff factor is introduced. Hello, am I audible? Hello, hello, hello.
Hello, hello.
Am I audible?
Yeah.
Just 1 second. Okay, just 1 second. So have you understood what I am trying to say? Huh? Alicia? Hello? Have you understood? You're
Yeah.
not audible.
Till yes, till the first paragraph, not the. I understood.
Huh?
Yeah, I understood the first paragraph, but
Okay. And the second paragraph?
I didn't.
Abnormal weight. What is abnormal weight? Weight is that weight that you have calculated without
I
using
don't.
the Vanta factor. If you do not use Vanta factor and you get some value, some molecular weight, then this one is known as your abnormal.
No.
I'm not able to see you. I'm not able to hear you. Hello, Alicia.
Yes, sir. Yeah.
I'm not you. You are.
Yeah. Wait.
Is there any issue from your side? Connection issue and all. Hello.
Yeah. No.
Yeah. Now I can able to see you properly.
Yeah.
Okay. See. So that we have discussed. I think you have understood everything. I think. Is it? Am I correct?
Yeah.
Or
The
is there
second
any?
paragraph I didn't. I wasn't
Okay.
able to hear from
So
the
see. Okay. Fine.
electrolyte.
So in the second paragraph, what is written here? Key if you calculate the same thing, if you use your formula C R T R L V P equals to your P naught A minus P T upon your P naught A equals to XB, or if for example, just 1 minute, like uh, more formulas like delta TB equals to your KB into M, or delta TF equals to KF into M. So if you apply all these formula to electrolytes that associate or dissociate, you will get your abnormal abnormal mass, abnormal molecular weight. This is the thing that I have explained you. Understood?
Okay.
Okay. You will get your abnormal weight. That's it. Abnormal weight how? If you apply the formula on these, which are on the compounds like electrolytes. So abnormal weights. Let's move on to the next point key about the electrolytes. Electrolytes. So there are two types of electrolytes: strong and weak. Strong electrolytes and weak electrolytes. Strong electrolytes are those that dissociates completely, associates completely. Okay, that associates completely. Oh, just one second. Okay, sorry. That dissociates completely, and that
Yeah.
partially dissociates. Yeah. This is your weak electrolyte, this is your strong electrolyte. Okay. Now, for example, if you have your AB, this will going to be dissociate like A plus B minus. If you have this one as 100%, this one as at 0%, 0%. After some time, it is T equals to 0 when the reaction is not started. But when the reaction is started, T equals to T time, then it would be your, let's say some, for example, 0% when the reaction is complete, TC 0%, and this one would be your 100% and 100%. So these are the electrolytes which are completely gonna dissociate. But these are what?
Partially.
These are not completely dissociate, these are partial. So if you see this is 100%, this is 0%, this is 0%. After some time t, it would be your 90%, it would be your 10%, let's say, it would be your 10%. So this is what? This is not completely dissociates. Understood? Example, for example, this one. This one is weak, but this is strong. HCl. HCl. This is strong. Understood? Fine.
Yeah. Yeah.
Now, this is the formulas for Vant of spectrum. Okay. I. I is your Vant Hoff factor. Total number of particles after dissociation or association. Means when the solution is formed. Divided by total number of particles before dissociation or association. Okay. Before formation of solution. For example, like CH3COH. This is what? This is one before the solution. So this is one. And after dissociation, it would be two. Two. Or a better example would be HCl. The better example for this it would be HCl. So if you see here, this is before. After adding, this will HC H plus Cl minus. So this is what? This one and 1 is 2, and before it was 1. So 2, I equals to 2. Understood?
Yeah.
And if you see here,
Understood.
normal weight is what? After formation of the solution. You'll get after formation of the normal weight is what? Normal is after if you apply I value. है ना? This is normal weight, experimental. If you get after applying the Vanta factor, you'll get the correct formula. No? And this one is your incorrect one before your solution. If you are not considering that I. Okay. Fine, and you can also tell this key this is observed, the colligative property that you have observed and the colligative property that you have calculated. You know? So all the formulas are in a different form. So see, let's start with your first case. Okay, in case of dissociation, in case of dissociation in strong electrolyte. Dissociation in strong electrolyte. Let's start from this. So let's take an example, NaCl. Okay. So how you gonna tell me the value of I? So
2 by
see,
1.
1 and 1. It would be 2 and 1. Correct?
Yes.
Okay, next question. Okay, I'm writing all these. You have to tell me the answer. Okay, tell me the answer one by one. See, this is how going to be dissociate.
A plus.
Am I correct?
Yes.
Hmm. So tell me the answer. For this one,
Is
what would
it?
be the answer? 3 by 1, 4 by 1. See, 1 and 3, it would be 4. 2 plus 1, it would be 3 by 1. 2 and 3,
Mm.
5 by 1. Am I correct or not?
Yes. Okay.
If you see here, 3 plus 1, 4, 4 by 1.
4 by
Very
1. 4
simple.
by 1.
Ah, very simple. So this is based on your strong electrolyte. But, but, when it comes to weak electrolyte, I have to add pages here.
Mhm.
So once again, yeah. Okay, see. So, am I audible?
Yes, sir.
Hmm. Just one second. See, now in case of weak electrolyte,
Why more?
you have to remember the formula. Okay, directly you have to just remember the formula directly. So the formula is I equals to 1. Write the formula I equals to 1 plus,
Okay.
or agar if you want, you have to, if you want ki in terms of alpha, if you want to write ki what is the formula in terms of alpha, so it would be I minus 1 and minus 1. In case of association, the formula would be your I equals to 1 plus alpha into 1 by n minus 1. So these are the formulas for your weak electrolyte. Formula of I of the weak electrolyte in terms of alpha, in terms of I. Okay, understood or
Okay.
not?
Understood.
Okay, so what do you understand by alpha? What is alpha? Can you tell me what is alpha?
Mm,
Hmm?
uh,
Alpha is degree of dissociation. What is degree of dissociation? It is there in your
mm,
class 11. Alpha is your degree of dissociation. I'll tell you what is it. It is degree of dissociation. From here it is association. Here it is association, and here it is your dissociation. What do you mean by degree of dissociation association? It tells us ki how much my solute or electrolyte is dissociated. For example, alpha is equals to 0.9. What I understand from this, it means that my 90% of the electrolyte is dissociated. Only 10% is left as it is. 90% it would be dissociated. Understood?
okay.
Yeah.
Yeah.
Okay, now. So let's move on to the next thing, which is just for 1 minute. Now let's talk about. Okay. So this is your note point. So all the carboxylic acids get dimerizes. And what do you mean by dimerizes? It means that it associates. See, this is carboxylic acid.
Mm,
This is your carboxylic acid. What is carboxylic acid? This is your carboxylic acid. See, COOH. And this is also your carboxylic acid. So carboxylic acid is basically dimerizes in benzene. So benzene is a solvent in which my carboxylic acid is dimerizes because of the intermolecular hydrogen bonding. So see here, one molecule is there, or if you see here, two molecules is there. Two molecules combines with combines to form one molecule. So half is my alpha. So if you want what is my I value of I, so for the value of I, you have to apply the formula of what, of your I equals to 1 plus alpha n 1
yeah.
upon n minus 1. So what is n? N is the number of electrolytes. So if you see, number of electrolytes is your 2. Now we'll
Okay.
discuss more about in through the questions about this. Okay, let's move on to the questions. Okay. So just give me 1 minute. I'll find some questions based on this. Okay. So this is the question which is based on alpha. Yes. Yeah. Okay. So this is the question for you. This is the question for you. Okay. So everything is there. Just solve this question first by using your mind. And I'm going to tell you the approach. So question is ki, what is the percentage of association? Alpha you need to find of acid if it
Mm,
is formed dimer. So it means that it tells me ki you need to find the alpha. For that you need to find from which formula you have to apply all these things. I equals to 1 plus 1 plus alpha multiplied by 1 upon n minus 1. This formula is going to be applied here. Okay, just solve it. Okay, and value of n is
okay.
what? Value of n is 2, because why? It is dimer is written here. So 2, and how you gonna find I? So formula of I have told you before. What is the formula of I? This is the formula of I for finding alpha, but there are some other formulas that I have told you before. What are the formula? In this question, the formula that is going to be required is M normal that you have observed divided by M abnormal. Okay,
Hmm.
through which you will find I, and then you'll get your answer. Okay, just solve this question. Hmm. When you're done, just tell me.
Okay. Could you solve
What?
Yeah, could you solve?
Okay, okay. See, so you didn't get anything. Like how gonna approach this question?
I don't know how to find I. The rest of.
Okay, see. So you see. But this is the last part. If you want to find the I, this is the last part. Before that, you need to solve basically for M normal. So 2 grams is there. See, weight of your benzoic acid. Benzoic acid is your 2 grams. Molecular weight of your benzoic acid is what? C6H5. It means that uh, 6. Can you tell me what is the molecular weight of benzoic acid? Just calculate it. 7 multiplied by 12 plus 6 multiply 1 plus 2 multiply 16. How much? What is the weight? Molecular weight.
112.
105.
12. 112.
112. Okay. 112. And what is written? See, 25 gram of benzene is there. So benzene is 25 grams. What is the molecular weight of benzene? It is 72 grams. Fine. Show depression in freezing point is equals to 1 point. So delta TF is equals to 1.62 K. Fine. Okay. Molar depression for freezing is itna. Okay. So molar depression क्या होता है? What is molar depression? What do you understand from molar depression? It is the constant that is given to you. KF. That is
Yeah.
4.9. So everything is given to you. Just you need to find first M, value of M. You have to find the value of M. Fine.
And
See, just apply the formula. delta TF equals to what? 1.62 equals to KF. KF into में M molality. So 6.2 multiply by your KF, which is 4.9. Fine. Multiply into M. M is your molality. Molality. So molality, number of moles. Number of moles is what? Your given weight divided by molecular weight. That you need to find. You do not have to. You do not need to put this one here. Why? Because this is the weight when it is there in your not in the when it is there when it is not added in the solution. It is before the solution. So this is weight that is there, which is there in the in its free state. But after forming the solution, the weight will be different. This is the colligative property. So that you need to find here. So divided by this, multiply by what? It is divided by volume of the solution, or weight of the solvent. What is it? It is weight of the
Weight
solvent.
of the solvent.
Yeah. So 72 divided by 1000. Understood or not?
Yeah,
Fine.
understood.
Correct. So just you need to find this one. For that, 1.62 equals to 4.9 multiply 2 divided by m 1000 divided by 72. So this one would be your okay. So zero point 0.7. This one is your 72. How many times it will be 72? 63, and no, it's not 72. So it's 1 minute. So it would be your 1, and this one would be your 3, and 12 is your 636. Yes. So just put the values, you will get your m equals to your 1000 divided by or multiply by 4.9 divided by your 36 multiply 1.62. Okay. So after calculating, you will get value of mv as your 392 divided by 162 multiply 100. Understood? You will get this expression. Understood or not? Bolo bhai. You're not audible. You're muted.
Yeah, understood. Yeah.
This is the calculation that you need to figure out by your own self. Okay. So this
Okay.
from here you will get it. Understood. Fine. Very good. Now the question is how to find this, because you need to find alpha. You need to find percentage association, and this percentage association
Yeah.
for this you need to find I. Because you know this, because it is written here, it is the dimer. So value of n, it would be 2. So the value of n, it would be your 2. Value is 2.
True.
And you know alpha you have to find, I you should know. So how you gonna find I? You by the process is what? To finding the abnormal weight, and the abnormal weight that you have calculated here is 392,162 multiply 100. And what is the real weight? Can you tell me what is the real weight?
112.
112. Let's find out. So 7, I have calculated 7 multiply 12. You'll get 7 multiply 12, 84 plus 6. Okay, plus how much? 32. So it would be 122, not 120. This one
Okay.
122. Okay. So just put the value. So normal weight that you have calculated is 122, and from here you will get this one. Okay, just divide this, you will get the answer. So for after dividing it, 122 divided by 392 divided by 162 multiply 100, you will get your final answer as your value of I as your 0.504. This is your 0.504 is your value of I. So just you need to put the value of I here. 0.504 equals to 1 plus alpha. 1 upon me 2 minus 1. You'll get 1 plus alpha minus half equals to 0.504. Understood? Bolo sir.
Yeah.
So the value of alpha
Yeah,
is,
understood.
yeah. So the value of alpha is after calculating, it would be your 0.9 0.992. This is the value of alpha that you need to find. So the question is this. So if you want this one is in percentage, just multiply this and you'll get 99.2 percentage. This is your final answer. The final answer is 99.2%. So again, let's again rethink, reobserve, or reanalyze the question. How this question is going to be solved. Initially, just after putting all the values of the atomic weights, you will get your normal weight. What is the molecular weight? Normal weight and normal. And after using this colligative property, you'll get your abnormal weight. Why? How you gonna get the abnormal weight? Because of the because of the association that is happening. And this association is happening, dimer is forming. So if the association is happening, then you'll get your abnormal weight. But in order to correct this, you have to introduce I here in this formula. So for that, the question asks me to tell me that what is the formula of alpha. So this is the formula for I equals to, this is the relation between your, I'll write it in a, so this is the between relation between your alpha degree of dissociation and your I Van factor. Understood? Now the colligative property will be pi equals to I CRT. Your delta TF equals to I KFM. Delta TB equals to I KBM. And your RLVP equals to P naught A minus PT divided by P naught A equals to IXB. Understood? So this is now the final colligative properties after correction. This is the correct formula. Till now that the formula that you are using is not the correct formula. Why? Because these are the formula only applicable for the compounds which are not going to be dissociate or associate. And these formulas are not applicable for any type of your compounds.
Compounds.
Yeah, so we are done with this question. Now this question is for you. Now solve this by your own self. Now I am going to tell you what is asked you. So you need to find by event of factor I. You need to calculate. You need to calculate dissociation constant for acids. For acids, you need to calculate the dissociation constant. So alpha is also you do not know. Okay, fine. And what is there? What is given to you? It is given to you is that the depression in freezing point observed for the strength of acid is itna. Okay. So delta TF is given to you as 0.050 degrees Celsius. Now, so what is written? Density of this one is given to you. Density is also given to you, which is 1.06 gram per ml. Fine. And what is there? Volume of acid is also given to you. Volume of acid is your zero point 0.6 ml. Acetic acid is given to you. Fine. So now you need to calculate this into molecular weight and normal mass. You'll get it. So m normal. How you gonna find m normal? By putting the values.
Molecular mass.
2 multiply 12 plus your 4 multiply 1 plus your 2 multiply 16. So this will you will get this. And from this formula you will get m abnormal. From this, you'll get I. And now after calculating the I, you'll get alpha. Understood the procedure?
Yeah.
Follow?
Same. Yes.
Yeah.
Yes.
Okay, now solve then. Then solve it. Basically, you do not need to find the alpha. In this question, you need to find Ka.
I.
K, Ka is your
Okay.
dissociation constant. This is your degree of dissociation. This is dissociation constant. But in the at this point I do not tell you what is the dissociation constant, so let it be as it is. Just solve for alpha, then after I'll explain you what is K. Okay, you just need to find alpha. After alpha you'll easily find K. Okay, so understood the procedure?
Yeah,
Okay, find it.
1 plus. Could you solve? Hello. No. Could you solve those?
Okay. See,
Yeah,
just solve this for what is the weight of my acetic
60,
acid? So two carbons are there, 24 plus 4 plus it would be 32.
32,
So 36, 28 plus
60.
32, 0, 5, 6, 60. So 60 grams is the normal weight. For abnormal, you need to see density is there, moles upon mass upon volume. So density is written 1.06. And what is the volume? Volume is zero point 0.6 ml. See, mass you need to calculate. For mass, just 1.06 multiply this zero point 0.6, you'll get your answer. Just 1 minute. 1.06 multiply by zero point 0.6, you'll get your answer as 0.036. 0.036. What is the answer? 0.036.
36.
0.036. 0.636. This is the weight in grams. Understood or not?
Understood.
This is mass. Okay. Now, so delta
Mm.
TF is 0.025 equals to what is the formula? KF. KF is written or not? KF is there or not?
Yes. Right.
Where KF is written or not? For KF, 0.6 density is this, and depression freezing point is this. Okay, so observed for strength of the acid, it was this. So calculate this one. Okay, fine. So I think here the value of my I am just adding this into a water. So for water, what is the value of KF? Can you tell me? What is the value of KF for water? बोलो.
Oh,
हम्म कितना बोला?
this
दो ऑप्शन 0.52 और
8.85 I forgot.
कितना? दो ऑप्शन है.
0.52.
वो एलिवेशन एंड बॉइलिंग पॉइंट. 1.86.
Yeah, okay. 1.86.
हाँ जी. 1 याद रखो इसको, ठीक है. 1.86 and then KF is written and then M molality. So weight is 0.636 molecular weight you have to find. Multiply this by 1000 divided by the volume which is there 1 liter. So for 1 liter it would be 1000. So 1000 and 1000 gonna cancel out each other. So just applying the formula you'll get your molecular weight as 1.86 multiplied by 0.636 divided by 0.0205. Okay. After calculating, you'll get your molecular weight. So what is the molecular weight? Just 1 minute. So 0.636 multiply this 1.86 divided by 0.0205. So you'll get your answer as 57.7 gram. 57.7 gram. Correct? Bolo.
Yeah, 7
Okay.
points.
This is your 57.7 grams. Great. Great. So now this one is your abnormal. Abnormal. This one is your normal. What I need to do? Normal upon abnormal. So 60 divided by what? Abnormal upon normal or normal upon
56.
abnormal? What is the formula?
Normal upon abnormal.
So 57.7. So you get I. What is I? So 60 divided by 57.7, you'll get your 1.03. The answer is
Mm.
1.03. 1.03. Correct?
Yes.
1.03. So you'll get I. Now solve for alpha. So for alpha, I equals to 1 plus alpha n minus 1. What is the value of n? 2. एसिटिक एसिड है.
2, yeah.
किसमें 2 हो जाएगा? 2 minus 1. Alpha in order to calculate 1 equals to 1.03. So after calculating, you will get your answer as 0.03 divided by 1 equals to alpha. So alpha ही आ गया तुम्हारे पास 0.03. ये अल्फा आ गया and in percentage it would be 30. It would be 3%. It would be 30 or
3%.
3. 34.
30.
Correct? Multiply by 100 na. If you want to calculate
100,
this
yeah.
in percentage, what you need to do? Yeah. So this one is your 30%. So alpha is calculated. Now dissociation constant. Next topic. Last one. What is dissociation? Because it is not a topic basically. It is there in our class 11th. Okay. Dissociation constant. So basically what is dissociation constant? K is your dissociation constant. Dissociation constant. For example, alpha A plus beta B gives equilibrium with gamma C delta D. Okay, so Ka equals to your concentration of your C ki power gamma, concentration of D ki power delta divided by concentration of A ki power alpha, concentration of B ki power beta. So this is what, this is your dissociation constant. This is your dissociation constant and this is your formula of the dissociation constant. That means concentration raised to the power of stoichiometry, concentration raised to the power of stoichiometry divided by, this is from the product side to your reactant side. And this is there in your class 10, class 11. If you're not able to understood this one, leave it. Just learn the formula for Ka. It will be C alpha square. What is the formula? C alpha square. And C is what? C is your what? C is your concentration
concentration.
in
Molar.
molarity.
Yeah.
Okay, in molarity. So alpha you have calculated. So K is your C alpha square. C is given to you. How you gonna find C? Concentration कैसे find करोगे? Molecular moles
Mm,
divided by volume. What is moles? How many moles are
yes.
there? So you know the weight. You know the weight. This is 60, and
Yeah.
this is what, this is your weight that you have calculated. So
Yeah.
0.636. So
Divided by 6.
0.636 divided by 60. This is what? This is moles divided by volume of solution. 1 liter. 1. Multiply by alpha square, which is 0.03 square. Understood or not?
Multiply by
Alpha square. C alpha square. C alpha. C is the molarity.
formula.
Formula is Ka equals to C alpha square.
Yes.
Yeah. So after calculating, you'll get the answer. So the answer would be, your final answer is your 1.78, 1.78 multiplied 10 to the power of minus 5. Okay, so this is your final answer. And such type of questions can be asked in your exam. This is the toppest level of question of your level. Okay, this is the toppest level for your concern, in order to your concern. Okay. So this is all about my Vanta
Okay.
factor. We are completed this chapter. Like just one thing is left, which is azeotropic mixture, which is a topic of 5 minutes. We'll discuss it in this class as well. But if you have any doubt, you can ask me. You have 5 minutes. Just tell me. Okay, let's take your doubts. So this is the second question that we have discussed. Anything that you need to find me, ask me. First thing, okay, just 1 minute. So in this page, I'm going to tell you the procedure. If I alpha or K A is asked in question, how to solve? How to solve? See, first thing is calculate normal weight. How you gonna calculate normal weight? By molar mass calculation. Simple molar mass calculation. Understood? Now second,
Yeah.
abnormal. How you gonna calculate abnormal? Just by colligative property. Okay. Now third point. Find I. I के लिए क्या करना है? take a ratio n normal abnormal. Understood? Fourth point. What do you need to do
Mm.
for alpha? Just apply the formula. If
Formula.
dissociation, then I equals to 1 plus alpha n minus 1. If association, I equal to 1 plus alpha 1 upon n minus 1. Okay. Now, fifth point. What is fifth point? If Ka you need to find, then how you gonna find Ka? यहाँ से alpha you can find it. Okay. How you gonna find Ka? Or you can apply direct formula of alpha. For association, the direct formula of alpha would be I minus 1 divided by n minus 1. Here, alpha equals to
Yes.
I minus 1 upon n minus 1. Okay. After reducing, you'll get this. After reducing this one, you'll get this. Okay. Now, last point for Ka, C alpha square. This is molality. Molarity. Moles divided by volume. Okay. Understood the procedure? Everything?
Yes.
Tell me. Any doubt?
No, sir, I understood.
Fine. So we are done with everything. Just one topic is left, azeotropic mixture. Let's just discuss it. This is a theoretical concept, just theory. So what is azeotropic mixture? It is based on Raoult's law. Azeotropic mixture. So these are constant boiling mixtures. What are these? These are constant boiling mixtures having having some composition in liquid and vapor phase. These compounds cannot be separated by fractional distillation. Let's take an example. Like for example, I am having A and B as component. I have mixed these components, and the boiling point is like this is having boiling point of 100 degrees Celsius. This one having a boiling point of 101 degrees Celsius. Okay. Like let's take more in more points, like 100.1 degrees Celsius. Can you separate these two mixtures? 100 degrees Celsius and 100.1 degrees Celsius. Can you separate this type of mixture? No. You are not able to
No.
separate this type of mixture through your fractional distillation conventional method. Okay. So you are not able to separate this type of mixtures. Like for example, these are constant boiling mixtures. It means that after forming the solution, the boiling point will be constant for them. Okay. So, but they are having some composition in a liquid and a vapor phase that their components cannot be separated. Why? Because 100 degrees Celsius and 100.1 degrees Celsius is a very minute difference. Understood?
Yes.
And such type of mixture is very difficult to separate. So these are what? These are the azeotropic mixtures. What are these? These are,
Azeotropic mixture.
yeah. So now there is one. If the examiner asks you the question based on the azeotropic mixture, this thing you need to write. That should. Theory part is going to be there in your exam. Just you need to write all these things. So these solutions, these are what? These are the solutions that show large positive deviation from Raoult's law. What is written here? Minimum boiling azeotropes. What are minimum boiling azeotropes? It means that they show positive deviation from Raoult's law, and their boiling
Mm.
point of the solution will be less than the individual components of the solution. For example, A and B are mixed. Let us take this one is 100 degrees Celsius. This one is this one is 101 degrees Celsius. 100 degrees Celsius, 101 degrees Celsius. Fine. These two are
Fine.
mixed together. Now, when their solution is formed, AB is formed, then this solution is having a boiling point as 90 degrees Celsius. So it is known as your minimum boiling azeotropes. What are known as minimum boiling azeotropes? So these are the solution which show
Mm.
positive deviation from the Raoult's law. है ना? Remember the graph. Such type of graph is there. है ना? So this is your Raoult's law. And what is written? Positive deviation. So for the positive deviation, this is the positive deviation. So these are the compounds which show positive deviation from the Raoult's law. These are the things that show positive deviation from the Raoult's law. and their boiling point are lesser
Yeah.
than its individual components. So these are what? So these are the minimum boiling azeotrope.
Minimum boiling.
Example, for example, your examples of your positive deviations. Example of a non-ideal solution positive deviation. You have remembered the examples, na? Let's see the examples. The example is your of water and ethanol. Alcohol plus water is the
Yeah.
example of positive deviation. 100 degrees Celsius and 78.5 degrees Celsius. These are what? These are what? These are the individual components. So
Positive
there
degree.
is a very small difference in the boiling point. And small difference in the boiling point. And their solution having a 78. So 78 is lesser than 78.5 and 100 degrees Celsius. From 100 degrees Celsius and 78.5 degrees Celsius, 78 is lesser than both of them. So this is the example of your what minimum boiling is, and maximum boiling is opposite of it. Why? Because it is negative
Hmm.
deviation. It show negative deviation from the Raoult's law, and it is having a boiling point which is more than its individual components. Understood?
Yeah, understood. Negativity.
Okay. So this is all about this chapter. We are done with this chapter solutions. Now, is there any doubt in this chapter? You can ask me. Like we can from where we have started. From here, I think we have started from this question. Okay. So from this question we have started. So can you tell me if you have any doubt?
Hmm. No, this, no doubts in this.
Hmm.
No doubt in this one.
Okay. Next.
Yeah, I understood this as well.
Next.
Yes. Uh, what does the diagrams you drew mean?
Hmm.
The one T is equal to 0, T is equal to T. Could you explain?
This one.
Down electron. No, no, the one on the right.
This or this
The
electrolytes.
one below. Yeah, the electrolytes.
And what do you need to ask
Yeah.
me in this electrolyte?
This AB is equal to A plus B. 100%, 0%, 0.
Okay, so this is the percentage that how much reactant is there. 100% reactant is there. When the reaction is not started, this is 100%. And this is 0% because
Yeah.
product is not formed. After the reaction is started, then after the reaction is completed, this one is 0%, this one 100 and 100. Product will be formed 100%, and the reactant will be left to 0. This is the percentage of the return.
Okay.
Next.
Yeah. Yeah, understood this.
Next.
Yeah, understood this as well.
Next.
Yeah, understood this.
Next.
Yeah, understood.
Next.
Yes, understood. Yeah.
Next.
Yeah, understood.
Next.
This is- Yeah, understood. Same.
Next.
Understood as well.
Next.
Understood.
Okay. So